Okay, so I'm going to check and close that one. We're not going to cover the whole section. We're going to cover part of it. I want you guys write down the homework. Oh, it's not back on the board. We're not going to do the whole section. It will be part of it. So, section 9.1, properties of radicals. Do you guys know what a radical is? What's that word? Besides like a really old word to say something really old. Yeah, that was usually more like rhyme, just like radical. Radical was kind of in the 80s then. What's a radical? It's like the opposite of a square root. No, not the opposite. Involving a square root. Now, it's called radical though because if you guys have seen, and have you seen it this year before? Have you seen other numbers being an index besides just like the understood 2? Sometimes there's a cube root or a fourth root. So the radical is just the sign itself, not thinking about whether it's a square root like an understood 2 or whether it's a 3 or 4. The radical is the sign itself. We call these radical expressions because maybe there's only one radical, maybe the whole thing is radical, maybe they're like separated up, right? Dylan. If you guys are being distracted,
This one.
You're okay. Someone's music is too loud. Josh just happened to look like and be like. Turn it down just a little bit. Okay, go back, we're good.
Sorry. The song was
You just heard. Okay, here we go. Now I get where you're coming from. Alright, so, I heard stuff right. Okay, so, for letter A, what do you guys think? How do we simplify? Jay, notes open. Piece of paper just for scratch, you can look on this. Josh, what do you do?
Well, first you have to do 36.
Square root, right?
Square root
What's that?
36 is 6. That's square root is 8.
And then we can finish.
Add them together.
Okay, do you guys agree with that? Okay, that's not bad. And letter B, remember PEMDAS, the radical, the square roots, the 36 and the 64. I could put parentheses around it. Old school, like snazzy calculators, would actually have you write this with the parentheses. And you would write it like this, and with the parentheses, it would understand square root the whole thing. But anyway, new calculators are pretty cool and don't do that. So guys, what did you do first before square root? What did you get when you added 36 and 64? When you square root 100, what do you get? 10. You just started solving each other, so you can probably catch up. My question to you is, these look kind of similar, right?
Yes.
But my question, are they the same?
Just double things.
Yeah. So is it important to do? You okay? No, let's put this one. Is it still 2?
No.
So then, can we say that they're the same? No. So do we have to be careful in trying to... Jay, what's going on? I don't know, some of the music is too loud in your head. So that was Jordan. Sorry, yeah, turn it down just a little bit. No, you're okay, I know.
So that's why I like it. That's all the people like class.
Yeah. Okay, so then 14 doesn't equal 10, right? So then we have to say, and we have to be, well, basically really careful to say do PEMDAS when it's necessary. Let's focus back in. Do PEMDAS when it's necessary. I swear you guys a generation is going to be all done. You're 30 years old. You'd be like, oh, okay. Yeah, seriously, right? Anyway, between that and like heart attacks and like 10-year-olds. So, coming back. As a bad that's because of the rise of fast food. Kiddos, are these the same?
Yeah.
Why not? What did you do to solve in letter C?
Square.
Square root of Diego. 8 minus is. Now hold on. What's on the other side?
It's the same.
60. Wait. 64 minus 36 is 28, right? Did anybody have a calculator? Did you figure out that's actually like a decimal? It's between 5 and 6-ish.
0.5.
It's kind of rounded, right? Is it closer to 25 or 36?
Still half.
Yeah. So wait, pause. Do you guys see how 28 is kind of close to 25, and the square root of 25 is 5? So we can say it's 5-ish.
Yeah.
How about that?
Yeah, but you said.
How about that?
You said point.
But here's the long story short. Wait, pause, come back. Well, for right now, we're approximating. We're not getting too crazy. We haven't really talked about how to simplify this. At least, we're not going to do it in our warm-up. We will in class. Long story short, are they the same?
No, sorry.
No,
Yeah.
no,
Looking at a
no.
different.
So, is it important to do PEMDAS?
Yeah.
See,
Okay, last one. Oh, we have 4 more. Well, it's 5 point. No one had a calculator, so I didn't. There is a better way of writing it, Diego, but we're not talking about that right now. What is the square root of 4? 2, right? What's the square root of 9? 3. Multiply 2 and 3. No big deal.
Oh, this is easy.
But wait, what's 4 times 9?
It is 36 square.
Wait a minute.
And then the 6.
I wonder if that is just like a really special example, or is that always true? Let's try and see what's going on here. What's the square root of 100?
10.
What's the square root of 4?
2 over 2 is 5.
I mean 5.
Well, easy.
Hey, calm down. What's it? 10 over 2 is 5. Wait, what's 100 over 4? Yeah. Some of you guys already got it. Did they know this? Yeah.
20.
Good job. 25. What's the square root of 25, Angel?
13.5.
Got it. Hey, I think I see something here. You guys notice it helps you guys. Yeah.
Ah, they're the same.
Multiplication and division. So, what does that mean?
It means that most of the time, I heard the voice. I thought it was
Pause. Get your hands on that. Let's keep going. So, as you guys are looking at multiplication and division, we can go and say, hey, those seem to match, and hey, those seem to match. Why is this a cool thing? Kiddos, we had really nice, really ideal questions. In the sense that, didn't we know the square roots of everything on stage? Except for, what was the one weird one that we kind of were like, yeah. This one we were like, not exactly sure what to do with.
So would you leave it like that or?
Well, there's a better way of writing it for sure. And we're going to talk about it in this section, because this section is called, you guys see it? Properties of radicals. And basically the biggest direction, you had directions there, there's certain words you see repeated a lot. The biggest, or the most common direction is simplify. The most common direction in this is simplify. But what I want you to be able to see is for multiplication and division only, I'm going to put a big old box around it. For multiplication and division only, we can take something that looks like it needs PEMDAS, looks like it needs to be tied, we can split it up and solve. Something that looks like it needs to be tied together, we can split it up and solve, which is going to be really helpful for us in this section, okay? Let me go ahead and get you guys writing down some notes. I need to go answer a couple questions in the back.
So I saw everything about it. Yes, sir. Yeah, I know. So, yeah, no, yeah. This. Solve everything.
I called you. Yes, I called you.
Okay.
Get me a nice note. Does that make sense?
Yeah.
Angel, are we writing it all down? Have every
Yeah.
single word?
Did you see anything?
I do. That's what he says. He's one of the front there. Josh. Try to get Angel focused. Angel focus.
Liam, ¿cómo se llama el chino?
Why is it over here?
Because they forgot to get to here.
Where are you going?
Looking to eat. We have underwriting.
If anybody has? Ask the people around you if they don't do that system. Has anybody ever read pen that Diego can borrow real quick?
Yeah.
Jasmine?
I do.
Angel?
I got you.
Do you have something else to write with?
No.
Diego, give it right back after you use it. He just uses it for kindness.
Alright, that's fine.
Jazzy, can you grab my iPad and set something back to me? Jazzy.
I think you should close your eyes.
Alright, kiddos in the front. Let me give you guys a couple examples. I want you guys to think about it. Dylan, are you writing? Jasmine, are you writing? Haley, are you
Yeah,
writing?
I am right.
No, I just wrote that 2 seconds ago.
Okay, my
So we find the
Well, look at what I say above. Factor out the constants and the variables. So I'm going to give you a hint. Actually, let me change this real quick. That's way too easy. Let's do 48 equals. I would do 2 times 2 times 2 times 2 times 3. That's what I want you guys to do to start.
That's too much.
Done.
No worries, I'm coming. I've answered all the questions in the back. Thank you guys for your patience. I really appreciate it. Now let's focus back on it. Okay, ready? Okay. I'm in. I'm here. Square roots. Do you guys remember with square roots? Let me just do a quick little off to the side to help us out in preparation. Square roots. Remember, there's no number written up here. Okay? Square roots are looking for pairs. Cube roots, you're looking for triples.
What do you mean by triple?
Pairs of 3. I don't like saying pairs because that usually just is 2. But if you want to think about it, we could say pairs of 2 because that kind of works a little bit better.
Yeah.
Okay, so then we could do instead of triples, we'll say pairs of 3. Yeah, that makes more sense. Okay. And we could keep on going to a 4th root, you're totally right, it'd be a little more, and we're looking for pairs of 4 or quadruples. You actually start thinking about like triplets and twins, and so that just starts getting more confusing. So, you guys see down here that in letter A, that's the square root, right? Okay. That's the okay, Square root, looking for pairs. Do you guys see any pairs?
Yeah.
Yeah, I see a pair too. I see another
Yeah,
pair, right? Now, if you guys like, here's what we could do with 48. We could go ahead and say, you know what, 48 is the same thing as 4 times 4 times 3. That's true, right? 2 times 2 is 4, 2 times 2 is 4, and then 3, well, he's kind of low man out. Now, did you guys just see how we were able to split up multiplication? Remember how I told you the multiplication? Wait, pause, I'll show you. Didn't we show how multiplication you can split up?
And then it turns into 2.
A single multiplication under a root can be written as 2 separate roots. So what I can do is take that 48, make it root 4 times root 4 times 3, and be like, wait a minute, I know root 4. What's root 4? 2. I know root 4. What's root 4? I don't know root 3. Okay, well, he stays.
You wouldn't put 1.
I don't know root 3. On the page before, we were trying just to show it wasn't equal, so we estimated. Now we're trying to be Angel. You asked me a question. On the page before, we tried to estimate, so we guessed a little bit to see the number-ish. Now we're trying to keep it precise. We're solving a math problem. Does that make sense? Okay. So, guys, would we keep that 2 times 2 times root 3? Kaylee, go ahead and turn towards me. A little too much distraction. Would we keep it 2 times 2 times root 3? Does that look like a nice answer?
No.
2 times 2 is 4. My question, can I make that root 12?
Yes.
No.
I'm trying to trick you. No, the 4 is on the outside, the 3 is on the inside. 4 can visit 3, but he can't go inside the cell.
Oh
I'm just making up something. I don't
no. Go.
I'm not gonna say.
know. 3 stuck under the square root.
So you just keep.
So, I grouped them into pairs. So then I said 2 times 2 is 4, 2 times 2 is 4. I split that up. Multiplication, I'm allowed to look at each of these separately with the roots. So what is root 4? 2. What is root 4? 2? I don't know that one. Can't simplify him anymore, not precisely. What is 2 times 2? 4. That's all I can do. I can't multiply anymore. Just think that square root is keeping the 4 out. You can't connect. Okay?
So then, if you got a problem like
That is actually where we stop. We have simplified it as far as we can go. Look at the top. Ready? To simplify radical expressions without fractions, we factor out the constants and variables under the radicals. So we look at the number, and we try to factor them down. Now, actually, to help us out with simplest form, because we go until it's simplest form, I'm going to go ahead and write that right here. Simplest.
Mr.
Yeah, but
What about this?
thank you. That's the simplest form, so we stop. Now some of you are like, well, I don't know the simplest form. Well, hold on, let's do one more example, and then we'll talk about the simplest form. What do you guys think I'm going to do on this guy? Yeah, take 75 and break them down and say, well, 5 goes in, right? How many times does 5 go into 75? Yeah, it's a B, as in 4. 5 goes in how many times?
No, what are you saying, kid?
Wait, isn't it easier to do 25 and 3, like quarters? Doesn't that sound easier? 3 goes in 25 times, but we could do 3 times 5 times 5, and don't you guys see a pair? But if your mind could see this, don't you see he's a nice one? I wouldn't mind being under a square root. I don't mind 25. Or you can keep on going and see that pair of 5. So I'm going to rewrite it as 3 times 5 times 5 is 25. Why did I do that? Because I need to split these up. They're going to behave differently, right? What's the square root of 3? What's the square root of 25?
5.
Yeah, now hold on, careful.
Where do you put 5?
How am I going to write this? Can I write it like root 5? I'm not sure if I can. Yeah. Just like we do with variables, how we write the coefficient or the number before it, just for sake of it looking nice. Same thing here. We're going to write it 5 in front, root 3 after. Does that make sense? Justin.
Well, how does it be squared?
Now, here's the dilemma. I was just doing all this time the constants, and we did a great job with the constants, but Justin just brought up a good point. Wasn't there somebody else back here? Uh-oh. Who else?
Do you put 5 now?
Yeah, we can think of, hold on. Can't we think of the b squared and break him apart and say he's b times b? Okay, so what if we were to say the b squared is b times b? Kiddos, isn't that a pair? Oh, well then, hold on. So I don't mind the b squared because, here's what's crazy. I'm going to just tack them on to the end. What's the square root of b squared? Who is squared in b squared? B. So we just kind of left off part of the problem. Who do you think is going to be in front of the root 3? Kaylee got it. 5b. You see it? The 5's going to be in front, the b's going to be in front, the root 3, well, he's at the end, he's stuck in the radical. I can't nicely, perfectly simplify that. Okay? Now, hold on. Didn't I just say a second ago we should talk about the simplest thing? How do we know when we've gotten as far as we can go? What does simplest order or simplest form look like? Let me give you guys a second. These are the conditions for simplest form. Hey, don't worry. The video's going to be online. I'll be it now. Or I should say over the weekend. That way we're ready to go on Monday. That's a little small. Make it a little bit bigger. Simplest form. There are 3 different conditions. All 3 of them are important, and all 3 of them have to be true to be in simplest form. I'm trying to get your guys' nice homework page ready so that you guys can see it. Kiddos, I don't mind if you finish a little early and you're waiting on me and something like this to talk a little bit, but what I do get bugged by is people that are talking that haven't written all that down. That's what I get bugged by. You're distracting others. You know what I mean? Aiden, give me just 1 second, buddy. Thanks, kiddo. Jordan, make sure you have enough time. Just for the sake of not. Okay, so no radicand. Wait, what's a radicand? Radical is the sign. What do you think a radicand is?
That could be radical.
It's what's inside. Radical is the sign. Radicand is what's underneath or what's inside. Are you going to put that away?
So radical is the sign.
Radical is the sign. Radicand is what's underneath. So you think I have the square root and whatever's underneath. Radicand. I don't know.
So the radicand was going to be 46.
Yeah, the 48 or the 25 or the 36, stuff like that. Does that make sense?
Yep.
There it is. Okay, we'll get back to the homework in a second. I just want to get the page so you guys can see it. Okay, let me give you guys a few examples, and I want you guys to answer for me. You don't even have to simplify. Homework doesn't even start with simplify. It just says, is it in simplest form, yes or no? Tell me why or why not. So let's start with this one. What if I was to give you something like square root of 36x? What do you guys think?
6.
Is it in simplest form the way it's written right now?
No.
No, because square root 36, I can do that, right? Now question, could you square root the x part?
No.
No, because it's not a pair. It's not x times x, right? It's not a pair of 2. But we could simplify more. So all we would answer is, ready? No. Square root of 36, just that part, can be simplified. If you want to be super snazzy, you can actually say, hey, square root of 36 can become 6. That's cool. Right? What if I was to give you another one? Let's go a little bit harder. What if I was to give you this one, letter B? How about the square root of, let's do 40x cubed. Oh, sorry. Thinking. Please put it on my desk, Jordan. Thanks.
Should I staple them together?
If you use your scratch paper, please. Square root of 40x cubed. Haley said no.
I say yes.
Jay says yes. Haley, why did you say no?
I say yes.
I kind of agree with you, if that helps. Is yeah, I like that. Let me help her out a little bit. She said because of the x cubed. Kiddos, if you were to expand that, my question, is there a pair of x's in there?
Yes.
Yeah. Now, is there more than that? Yeah. Are we going to have to learn how to deal with that? Just on my desk, Jordan. That's good.
Yeah, the staple's broken, so.
Oh, you just put the paper with it. I'll figure it out. Thanks, kiddo. Thanks, Mom. But, hey, it wasn't just because of the x cubed. Did anybody figure out that the 40? Wait, what's going on with the 40? Oh, come on. You can't do 40, but what's inside 40?
4 times.
It's gonna be 2 in the other.
The 10 I can't do, but the 4 I can, right?
Yes.
Right? Yeah. If I was to write it all the way out, if I was to write it with maybe 2 times 2 and then 2 times 5, there's a pair in it. There's a pair of 2. Right? Now, let's go ahead and do this one, because actually, guys, you could have simplified this. This is actually going a little bit beyond this section in homework, but the next section asks you to simplify. How would you simplify letter A?
Wouldn't you just simplify it for 6?
I'm going to actually write my explanation real quick. Square root of 40 and square root of x cubed have pairs of 2. Can I say that? Dylan, what are we talking about? Hang in there. What would 36x become? We know square root of 36 is? Yeah. We could split that up, and wouldn't we get 6 root x? Doesn't that make sense, kind of?
Yes.
Does anybody know what this one would become?
Yes.
So
Barry, what would it become?
2x on the outside and the inside is like 10x.
Good, we could do the square root of 4 times the square root of 10 times the square root of x squared times the square root of x. This one we know. Pause. This one we know. This one we know. This one we don't. And this one we don't. Okay, guys, we're going to work more on Monday on this, especially for people in the back. So
Okay.
But wait, listen. Even though this will be due on Tuesday, some of you are like, I have more time over the weekend. I would rather.
Oh, yeah.
It'll be due on Tuesday. Pause. Watch. If you didn't turn in your test corrections, what do you need to remember to do?
Grade 7.
Give it to you grade 7 after school, right? Okay. Get on your quick test as soon as you have it. People taking the test, you have a little more time. If you're not taking the test, you can check out the video. The notes will be on there. Thank you. The test is on my desk. Thank you. Bye, Molly. Good job in the play. Have fun this weekend.
I'm ready, Miss D.